In this section, 2.4, we'll talk about describing the spread of quantitative data. Our learning objectives for this section include calculating the range, the standard deviation, knowing the properties of the standard deviation S, and understanding how we can interpret the magnitude of S using the empirical rule. The range is a measure of the entire data set from the least data value to the greatest data value. So it hopefully will make sense that the formula for calculating the range will be the maximum data value minus the minimum data value. Because the range is calculated using the two most extreme data values of the entire data set, the range is actually very affected by outliers, and so the range is not a resistant measure at all. Here we have two different data sets, and we can calculate the range of these data sets. We would want to look at the maximum data value minus the minimum data value, and here 78 minus 72 will give us 6. And then for the second data set, we will be doing 84 minus 67, and that will give us 17. A second way that we can measure the spread of the data set is by looking at the standard deviation for that data set. And to understand what standard deviation means, we should look at the root word deviate. Deviate means to move away from. Each data value in the data set will deviate from the mean of that data set. So to measure that deviation, or how far away the data value is from the mean, we just take the data value and we subtract the mean, and that will be a measure of how much that particular data value will deviate from the mean, and we call that a deviation. A deviation can be either positive or negative. If you have positive deviations, then that means that this value would be positive, and those happen when you've got data values that are above the mean. And then if you have negative deviations, that's going to happen when you have data values below the mean. So here, when we have the mean of 185.5, if you were looking at data values of 250, you're going to have positive deviations there. And then if you were looking at data values of 70, you're going to have negative deviations there. When all is said and done and you look at all of the positive deviations and all of the negative deviations, they will actually sum together to be 0. But none of this tells us what the standard deviation of a sample set is. The standard deviation of a data set will take into account every single deviation value for every data value that you have, and it puts them all together and summarizes them into one value. In order to calculate the sample standard deviation, we would use this formula, and the steps to calculating, we first need to know what the sample mean is, and then once we have the sample mean, we can calculate each deviation for every single data value, and then we want to square those deviations, and then we want to add those deviations up, and then we're going to divide by n minus 1, and last but not least, we need to take the square root. So obviously there are a lot of steps to computing the sample standard deviation. We'll do a very brief example here, and then you can look at more detailed examples in the other videos. Also, don't forget that your calculator will do this for you. In order to actually calculate the standard deviation of a sample, we need to go through those steps that we saw on the previous slide. Step number 1 is to find the mean. So our mean formula is going to be the sum of all of those x values divided by n, the sample size. Well, the sum of all of these x values, when we add all of these together, we will get 11,200. So that's our numerator, 11,200, and then there are 7 data values, so that's our sample size, 7, and when we divide these two, we get 1,600. So x bar is then going to be equal to 1,600. Our second step is to find each deviation for each data value. The deviations themselves, remember that formula, is going to be x minus x bar. So when we take each data value and we subtract 1600, we should get the deviations for each and every data value. And here they are. Note that some of these deviations are positive and some of these deviations are negative, but when we add all of the deviations up, they sum to 0, and that's as it should be. And then the next step that we look at from the previous slide is to square these deviations. So we take all of these deviations and then we will square them, and when we do that, we get these values. And then step number 4 is to sum those squared deviations. And when we sum those squared deviations, that's going to be the numerator of our sample deviation. And then the denominator is the sample size minus 1, in this case 7 minus 1. So when we take 214,870 and divide it by 6, and then we take the square root, we will end up getting 189.2. And that is our sample standard deviation. So now that we know what the standard deviation is and how to calculate it, let's look at some properties of the sample standard deviation. This measures the spread of the data. It's only 0 when all of the observations themselves are equal to each other, because if the standard deviation were 0, that would mean that all of the individual deviations had to be 0, and of course that would mean that all of the observations must be equal to each other. As the spread of the data increases, S gets larger. So if you're looking at a very large S, it means that the data is really spread out. Conversely, if you're looking at a very small s, that means that all of the data is very narrow and compacted together. The standard deviation does have units. It has exactly the same units as our data values. And the standard deviation is not a resistant measure. It does end up skewing when you have outliers, and it skews in the direction of those outliers. And now we'll take a look at the empirical rule and its relationship to the magnitude of S. The empirical rule is a really powerful rule in statistics, but it only applies to these distributions that have the nice, normal, bell-shaped sort of curves. And what the empirical rule says is that if you go out from the mean 1 standard deviation in either direction, then you've got 68% of all of your data values in this range right here. So here you see we've gone out 1 standard deviation in the positive direction and 1 standard deviation in the negative direction. So we have 68% of our data in this square right here. And then it tells us more than that. It tells us that 95% of our data is going to be within 2 standard deviations of the mean. So going out again from the mean, going out 2 standard deviations, 1 in the positive direction and 1 in the negative direction, we've got 95% of our data in this box. All or nearly all of our observations are going to be within 3 standard deviations. In that way, the standard deviation of a normal distribution tells us an enormous amount about how spread out our data exactly is.